The wind scours the ice until it sings, a low metallic sound rolling across a white horizon with no edges. In this cold, breath crystallizes before it can escape the lungs. Metal shatters, skin fails, and yet massive bodies move with patience and purpose, leaving dark tracks across the snow that vanish almost as soon as they appear. This is not a place life should choose. It is a place most life flees. But here at the top of the frozen world, snow bears remain, not trapped, not stranded, but adapted. Their presence is deliberate, shaped by deep time rather than desperation. Today, we're diving into why snow bears choose the cold instead of escape, how evolution, physiology, behavior, and ecology bind these animals to an environment that seems actively hostile, and why leaving it behind is not the advantage it appears to be. The ice does not arrive suddenly. It advances over thousands of years, creeping southward with falling temperatures, reshaping coastlines, sealing oceans, and opening corridors of frozen sea. During the last major ice ages, this slow transformation created a new world at the top of the planet, one that rewards endurance over speed, insulation over agility, and patience over migration. It is within this shifting boundary that snow bears begin to emerge. Genetic evidence shows that polar bears split from brown bear ancestors roughly 400,000 to 600,000 years ago, during a period when repeated glacial cycles dominated the northern hemisphere. These ancestors are not trapped in the Arctic. They could retreat south with the forests and tundra. Some do. Others remain near the ice margins, where seals concentrate along frozen coasts. Over generations, those that linger gain a quiet advantage. The cold filters out competitors. Food becomes predictable, if difficult to reach. Selection begins to favor bodies that do not escape winter but function within it. Fossil records and DNA analyses reveal how quickly this divergence accelerates. Within a relatively short evolutionary window, polar bears develop skulls longer and narrower than brown bears, optimized for gripping slippery prey. Their teeth shift from grinding plant matter to slicing flesh and fat. Their limbs elongate, improving stride efficiency across ice and snow. These changes are not random improvements. They are commitments. Each adaptation narrows the animal's options while strengthening its performance in one environment. Evolution does not reward flexibility in all cases. In extreme environments, specialization often outcompetes generalism. For early snow bears, staying near the ice means access to seals year after year. It also means fewer rivals. Brown bears that attempt to follow the same path struggle. Their metabolism, fur density, and foraging strategies are tuned for mixed diets and seasonal abundance. On the ice, inefficiency is lethal. The bears that survive are those whose bodies and behaviors align precisely with the cold. Over time, the Arctic stops being a temporary frontier and becomes home. The ice is no longer a seasonal obstacle, but a permanent hunting platform. Migration away from it is not evolutionarily favored, because leaving the ice means abandoning the very conditions that shaped survival. What looks, from a human perspective, like entrapment is actually inheritance. Snow bears are not choosing cold out of stubbornness. They're the product of a lineage that succeeds because the cold removes alternatives. By the time modern polar bears appear, escape is no longer an option written into their biology. The cold is not merely tolerated. It is encoded into bones, genes, instincts, and expectations about where food exists. Leaving it behind would not be freedom. It would be a return to a world they are no longer built to survive. The cold does not challenge snow bears in the way it challenges most mammals. For them, low temperatures are not an external threat to resist, but a baseline condition their bodies assume at all times. Every layer of their anatomy reflects this assumption, from the outermost hairs to the deepest metabolic rhythms. What appears to be excess, too much fur, too much fat, too much bulk, is in fact precision. A snow bear's fur is not simply thick. Each hair is hollow, trapping air and reducing heat loss while remaining lightweight. The outer guard hairs repel water, preventing ice from forming directly against the skin during long swims. Beneath them lies a dense undercoat that insulates even when wet. This system does more than retain heat. It stabilizes body temperature so effectively that overheating becomes a greater risk than freezing. Field researchers frequently observe polar bears rolling in snow or swimming in icy water not for play, but to shed excess heat generated by movement. Under the fur, the skin itself is black. This is not a visual adaptation, but a thermal one. Dark pigmentation absorbs solar radiation more efficiently, transferring warmth to the underlying tissues. While the Arctic sun is weak and seasonal, every fraction of absorbed energy matters during long hunts and extended fasts. Beneath the skin lies a thick layer of blubber, often exceeding 10 centimeters, that serves as insulation, buoyancy, and energy reserve all at once. This fat layer allows snow bears to endure months without food, particularly during summer when sea ice retreats. Internally, their metabolism reflects a life built around feast and famine. Snow bears can process enormous quantities of fat in short periods, converting seal blubber into stored energy with minimal protein loss. Their livers tolerate fat levels that would be pathological in most mammals. At the same time, their resting metabolic rate remains relatively low, conserving energy during inactivity. These traits are advantageous only in cold environments where high-calorie prey is available in bursts. In warmer regions, such physiology becomes a liability, increasing heat stress and reducing dietary flexibility. Movement itself reveals the cost of leaving the cold. Snow bears overheat quickly on land, particularly in summer. Their massive bodies, ideal for conserving heat, dissipate it poorly. Long-distance travel across tundra or forested regions raises body temperature to dangerous levels. This is not a temporary inconvenience, but a structural limit. Unlike migratory species, snow bears cannot simply walk away from the cold without paying a steep physiological price. The body of a snow bear is a system balanced on narrow margins. Every adaptation assumes ice, cold water, and energy-dense prey. Remove those conditions, and the same traits that once ensured survival begin to work against them. Staying in the cold is not a preference or a habit. It is the only environment where their biology operates as intended. On the ice, the world narrows to sound, scent, and patience. Snow bears do not chase prey across open ground or rely on speed. Instead, they hunt within a landscape defined by cracks, pressure ridges, and breathing holes. Features invisible to most predators, but essential to survival here. The sea ice is not an empty expanse. It is a living map, and snow bears read it fluently. Their primary prey, ringed and bearded seals, must surface regularly to breathe. In winter, seals maintain openings in the ice using their claws, returning to the same holes again and again. Snow bears learn these patterns. They wait motionless for hours, sometimes days, positioned downwind, bodies flattened to reduce visibility. When a seal surfaces, the strike is sudden and final. This strategy, known as still hunting, minimizes energy expenditure in a place where every calorie matters. Field studies using GPS collars and direct observation reveal how tightly hunting success is linked to ice conditions. Bears time their movements with freeze-up and break-up cycles, following the seasonal advance of sea ice across continental shelves where seal densities are highest. The ice provides both access and advantage. It supports the bear's weight while limiting the seal's escape routes. On land, this balance collapses. Seals disappear. Caloric intake drops dramatically. When forced ashore during extended ice-free seasons, snow bears may scavenge carcasses, consume bird eggs, or forage for vegetation. These behaviors are often cited as signs of adaptability. In reality, they represent nutritional failure. Terrestrial foods provide a fraction of the energy required to maintain body mass. Long-term studies showed declining body condition, reduced reproductive success, and higher cub mortality in bears spending prolonged periods on land. The ice also structures movement. Snow bears travel vast distances, not in search of warmth, but of optimal hunting platforms. Satellite tracking has recorded individuals covering thousands of kilometers annually, drifting with moving ice rather than walking across land. This passive transport conserves energy and positions bears where prey will emerge next. Escape, in the form of permanent migration southward, would sever this relationship between movement and food. Even risk is shaped by ice. On land, encounters with humans increase. Competition with brown bears intensifies. Parasite loads rise. The ice, harsh as it seems, is predictable and relatively safe. It filters threats as efficiently as it filters prey. For snow bears, the ice is not merely a hunting ground. It is the structure that makes hunting possible at all. Leaving it behind does not open new opportunities. It dismantles the only system in which their behavior remains effective. Cold does more than freeze water and harden landscapes. It reshapes entire ecosystems by narrowing who can participate in them. In the Arctic, survival is restricted to a small set of organisms capable of functioning under prolonged darkness, extreme temperatures, and seasonal scarcity. For snow bears, this biological filtering creates something rare in nature. A simplified world where competition is reduced, roles are stable, and evolutionary advantages are protected rather than challenged. In most ecosystems, large predators exist in constant tension with rivals. Energy is spent not only on finding food, but on defending territory, avoiding dominant competitors, and navigating complex social hierarchies. The Arctic removes much of this pressure. Few mammals possess the insulation, size, and endurance required to operate on sea ice. Wolves cannot pursue prey across shifting flows. Brown bears, despite their strength, lack the physiological tolerance for long hunts in sub-zero conditions. As a result, snow bears occupy an apex role with little direct interference. Cold also suppresses biological threats that thrive elsewhere. Parasites, insects, and many pathogens struggle to complete their life cycles in environments that remain frozen for much of the year. Compared to temperate bear species, snow bears experience lower parasite loads and reduced exposure to disease. This does not make them invulnerable, but it removes a constant evolutionary pressure faced by animals in warmer regions. The cold acts as a barrier, limiting not just competitors, but invisible enemies as well. As temperatures rise, this protective simplicity begins to erode. Along Arctic coastlines, encounters between snow bears and brown bears are increasing. These overlaps reveal how finely balanced the snow bear's niche truly is. On land, brown bears often dominate access to food. They are more aggressive, more flexible in diet, and better suited to terrestrial competition. Snow bears, adapted for wide, low-density ranges shaped by ice movement, struggle in crowded landscapes where avoidance becomes difficult and energy costs rise. Hybrid bears have been documented, sometimes presented as evidence of adaptive potential. In reality, hybrids occupy an unstable middle ground. They lack the full hunting efficiency of snow bears on ice and the ecological versatility of brown bears on land. Rather than representing a solution, they expose the limits of blending two highly specialized evolutionary paths. Even reproduction reflects the advantage of cold. Snow bears rely on snow dens, stable, insulated structures that persist through winter storms and protect cubs during early development. These conditions are rare or unreliable outside cold regions. The Arctic does not merely support adult survival. It safeguards the next generation. In this stripped-down world, cold preserves clarity. It reduces noise, competition, and unpredictability. For snow bears, remaining in the cold is not an avoidance of challenge. It remains within the only environment where their evolutionary strengths retain meaning. The ice that once defined certainty now fractures earlier each year, retreating farther from shore, thinning before hunting seasons can fully unfold. Snow bears respond not with migration, but with persistence. They follow the ice longer, swim farther between flows, and fast for extended periods. These are not new behaviors. They are extensions of strategies shaped for a world that changes slowly, not abruptly. Biologists tracking individual bears observe remarkable endurance. Some swim for days without rest. Others delay reproduction, waiting for conditions that may no longer return. These responses reveal both resilience and limitation. Evolution equips organisms to survive variability within familiar bounds. It does not prepare them for rapid transformation beyond those bounds. Snow bears are not failing to adapt because they lack intelligence or effort. They're confronting the outer edge of what specialization allows. Unlike generalist species that shift diets, ranges, and behaviors with relative ease, snow bears are locked into a biological contract with the cold. Their bodies expect ice. Their instincts assume seals will surface. Their energy budgets depend on brief windows of abundance followed by long, predictable scarcity. When those windows collapse, there is no alternative system waiting to replace them. What makes this moment scientifically revealing is not simply the risk of loss, but the clarity it brings to how evolution works. Adaptation is powerful, but it is not flexible in all directions. The very traits that once ensured dominance now restrict options. This is not a tragedy in the human sense. It is the consequence of success taken to its extreme. The future of snow bears remains uncertain, not because science lacks data, but because the environment they are adapted to is vanishing faster than evolutionary change can track. Conservation efforts focus on preserving ice, not relocating bears, because relocation misunderstands the problem. Snow bears do not belong somewhere else. There is no equivalent habitat waiting beyond the Arctic. In this sense, their story is not only about survival in the cold, but also about the cost of belonging completely to one place. Snow bears reveal how life can become exquisitely matched to a narrow slice of the planet, and how fragile that match becomes when conditions shift. As the Arctic continues to change, snow bears stand as living records of an older world, one where cold was stable, predictable, and sufficient. Their continued presence is not a refusal to escape. It is a reminder that some forms of life are not meant to run from change, but to endure it precisely as they are until endurance itself reaches its limit.